Okay, a bag contains 3 red marbles and 4 blue marbles. 2 marbles are drawn at random without replacement. So let's take 2 events over here. The first event is that the marble is red. Since it is given, the marble is this. Okay, the marble is red. This is the first event. And the second event be the marble is blue. Now, if I consider a bag which contains 3 red and 4 blue, 2 marbles are drawn, out of which I am drawing 2 marbles. Okay, 2 marbles are drawn without replacement. Without replacement means we are not putting them again. If the first marble drawn is red, what is the probability the second marble is blue? Okay, now if the first marble drawn is red, what is the probability that the second is blue? That is, now what exactly is asking? Probability of A and B. That is probability of getting this event is also occurring and this event is also occurring. That is, the first marble is red and the second marble is blue, which can be solved by using conditional probability. I can use P of A into P of B by A, or else I can also use P of A intersection B is equal to P of B into P of A by B. Now it depends on you, whichever formula you're using, whichever formula you're comfortable with, you can go for it. So what is P of A? Now probability of A is A is nothing but red. So there are 3 marbles out of 7. And now the second event says probability of B when A has occurred. See, this is nothing but probability of B when A has occurred. So when I say probability of B when A has occurred, since A event has already taken place, that is, one marble is already red. Since one marble is already red, okay, one marble is taken out from this. You just have how many marbles remaining? 6 marbles. So out of 7, one marble is taken. So you have 6 marbles remaining. And from that 6 marbles also, if I look at blue marbles, because probability of getting B, that is probability of getting blue, correct, when A has occurred. See, now total number will decrease, but it will not affect the number of blue marbles because the number of red marbles has decreased, but the number of blue marbles is still as it is. So it will be 4 by 6. And if you calculate this, you will be having 3 ones are, 3 twos are, 2 ones are, 2 twos are. The answer will be 2 by 7. The second way of doing this can be P of A intersection B is P of B into P of A by B. Now probability of B, that is getting blue. Blue is 4 out of total, that is 7. Now probability, what does this mean? This means probability of getting B, sorry, getting A when B has occurred. So probability of getting A when B has occurred. So when I say probability of getting A when B has occurred, so since B has occurred, that means one marble is already out. So we have 6 marbles with us. Okay, now probability of getting a red. Now a blue marble is taken over here. Na? What I have done is I have drawn one blue marble over here. So now the number of red marbles will not change. It will be same. Okay. So 3 ones are, 3 twos are, 2 ones are, 2 twos are. So finally you are getting again is 2 by 7 only. This is your answer, 2 by 7. Here, this case over here, looks more authentic since it already says probability of B, that is second when A has occurred, that is the first marble is red. So B is blue and A is red over here. So the first case that I have done over here, this one is more authentic. So we'll be following that. Now here again there are two events. The first event is a box contains 5 green pencils, 5 green and 7 yellow pencils. 2 pencils are chosen at random from the box without replacement. Okay. So again, I can say here the A event is first pencil. First pencil is yellow. First pencil is yellow. And even you want the second pencil also because both are yellow. So the B event is the second pencil is also yellow. Second pencil is also yellow. Now, how do I get this? The same way. P of A in and B, that is the first event and the second event should take place simultaneously. Now, if I use the conditional probability formula, it will be P of A into P of B by A. P of A into P of B by A. Now, what is P of A? P of A is probability of getting yellow. Okay. Now, yellow is 7 out of total 12 into probability of B by A. Now, what does probability of B by A mean? Probability of B by A means probability of getting B when A has occurred. When A has occurred. Now, what does this mean exactly? Let's see what does this mean exactly. So when I say probability of B when A has occurred means since A has already occurred, now one marble is already out of this 12. So I have 11 marbles. Okay, and also one yellow marble is already out. Since the first marble is already yellow, one yellow marble is already out. So you are remaining with, since one yellow marble is already out, so you are remaining now with only 6 marbles. So that will be 6 out of 11. And when you calculate this, 6 ones are 6, 6 twos are 12, that is 7 upon 22 is the answer. So in a sample of 40 vehicles, 18 are red. 18 are red. And out of this 18, if I say these are 18 vehicles, 18 red vehicles, these are 18 red vehicles, and 6 are trucks, of which 2 are red. Now, 6 are trucks, and 2 trucks over here, I can say 2 trucks. 2 trucks will be red because this 2 trucks will be red. So this will be in this 18 red vehicles. So out of the 40, 18 are red, and then out of this 18 you have 2 trucks which are red. So if I split the sum, okay, if I split it, like there are 40 vehicles, okay, so let me split it like A is a event that the vehicle is red. Vehicle is red. B be an event that the vehicle is a truck. Okay, because the bigger one is a red. So what he is saying, probability of, what is the probability of a truck? That is probability of B when A has already occurred. That is the vehicle is red. P of B by A, what he is saying? P of B by A. Okay, so P of B by A can be calculated by using, now since in the denominator you have A, P of B by A, this A becomes your sample space. This A over here becomes your sample space. So I'll write P of A at the bottom, the formula for conditional probability, P of A, and in the top you have, in the numerator you have intersection of A and B. So this is how the formula is. The formula says the P, if when I say P of B by A, this A is the sample space. This A becomes the sample space. And out of this A, we take the intersection part, that is P of A intersection B. Now, if I go for P of A intersection B, what will be P of A intersection B? P of intersection B over here will be probability of A and B both occurring. Okay. So if I say probability of A and B both are occurring, that means, can I say here there are only two vehicles out of how many? Out of 40. And probability of only red vehicles. Red, how many there are red? 18. So 18 out of 40. So can I say this will be 2 by 18, which is 1 by 9? That's your answer. So this question is for from a pack of well shuffled cards. You have two cards are drawn at random. Find a probability that both the cards are diamonds. When the first card drawn is kept aside, the first card drawn is replaced in the pack. Now, when I say first card drawn is kept aside, now what do I mean by first card drawn is kept aside? That means the card is not replaced. That is without a replacement. That is without a replacement. And the second will be definitely replaced, that is with replacement. So this is what it means, with replacement and without replacement. Okay. So there are two events over here. The from a pack of well shuffled cards, two cards are drawn at random. Find the probability that both the cards are diamonds. Now this question is just like both the pencils are yellow. Okay, kind of similar question, but here there are two cases: without replacement and with replacement. Okay, so we'll be using both the concepts over here. The first, I'll define that the first card is diamond. First card is a diamond. And again, I'll define the second event as the second card is also a second card is also diamond. So both the events are defined over here. Now what do I want? I want first card is kept aside. That is, find a probability that both cards are drawn. That is, first card is drawn and the second card is drawn without replacement. That is, the first event occurs and the second event also occurs. That is P of A intersection B. So that will be P of A into P of, this is kind of conditional probability, that is first event occurs and the second event also occurs. So I'll be using P of B by A. So P of A, probability of getting, okay, there are how many cards? There are 52 cards total, and out of that I'll have 13 diamond cards. So out of 52, I'll have 13 diamond cards, and P of B by A, that means I have taken the first event has already occurred. That is, first card is diamond has already occurred. Now there are 51 cards, and one diamond card is thrown away, that is without replacement. I haven't replaced it, so now there are only 12 diamond cards. These are total and these are now 12, so this will give me some answer. That is 13 ones are 13, 13 fours are 52, then 3 fours are 3 17s are, sorry, 3 17s are, 3 fours are 3 17s are, and 4 cancel. This will get 1 by 17 is the answer. This is the first case where the first card is kept aside. That is, you take one card and the second card is definitely taken after this event. But here, now the first card is replaced. So when I say the first card is replaced, what I do over here is the first event A and B over here will become independent, will be independent events over here, because the second card will not depend on the first. So since these events are independent, in case of independent event, the formula is P of A intersection B is P of A into P of B. This will not be P of B by A. This will not be P of B by A, since we are not using conditional probability, because probability of B will not depend on A. This is probability of second, which depends on the first. This here will be probability of the second only. It will not depend on the first because it is independent. Since it is without replacement, it depends on the first. since it is with replacement, when I replace it again, we have the same number of cards. Now, what do I mean by that is P of A is 13 by 52, and again P of B will be again the same because I still have 52 cards and 13 diamond cards. So 13 1 the 13, 13 4s are 52, 13 1 the 13, 13 4s are 52. That gives me 1 by 16 is my answer. So let's look at the sum number 5. So what it says, A, B, and C try to hit the target simultaneously, then the probability. So let's say I am taking event that A is taken as A can hit the target, okay, or A hits the target, B hits the target. This is what we are taking events over here, okay. So A event B, A tries to hit the target, okay, that is A can hit the target. Same way B event will be B hits the target, A hits the target, and same way B hits the target. B event is B hits the target. B hits the target, and C event will be C hits the target. C hits the target. So you have A, B, C, three events, the respective probabilities, that is A hitting the target, B hitting the target, and C hitting the target. Okay, this is what is given to you in the question. Now what it says further is find a probability that the target is hit exactly by one of them, hit not hit by any one of them, is exactly hit by two of them. Now this is a very tricky question. Let's see what things are given over here. So what I'll be defining over here is key P of A, that is probability of A hitting, is given to you as 3 by 4. Probability of B, that is probability of B means hitting by hitting done by B, is given to you. So P of B is also given to you as 1 by 2. P of B is 1 by 2. And P of C is given to you as 5 by 8. Now all the three probabilities are given to you. So the probability of not hitting the target means probability of A dash. A dash means not hitting the target. That is 1 minus 1 by 4. Okay, so if I find 1 minus 1 by 4, that is 1 minus P of A, that will be 1 minus 3 by 4, which will be 1 by 4. So probability of A not hitting is 1 by 4. Same way, probability of B not hitting will be 1 minus 1 by 2, which is 1 by 2. And probability of C not hitting will be 1 minus 5 by 8, that is 1 minus 5 by 8 will be 3 by 8. So these are the probabilities that you get for hitting and not hitting. Now let's see each of the cases. The first case says over here, the first case is A. Is hit exactly by one of them. Is hit exactly by one of them means what? So can I say is hit by one of them, probability that it is hit by one of them means either A will hit it and B and C will not hit it, or I can say probability of A is not hitting, B is hitting, and C is not hitting. That is, in the first case A is hitting, then second case B is hitting, and in the third case definitely C will be hitting. So A will not hit, B will not hit, only C will hit. So only one of them will hit. That means here you can clearly see in the first case A is hitting over here B is hitting, and here only C is hitting. So these are all independent events. Students understand, these are all independent events. So when I say these are independent events, I can directly split it like P of A into P of B dash into P of C dash. Okay, and this union is nothing but plus over here, that is P of A dash into P of B into P of C plus P of A dash into P of B dash into P of C. So when I put the values over here, P of A is 3 by 4 into 1 by 2 into what? 3 by 8 into 3 by 8 plus, so 3 by 4 into 1 by 2 into 3 by 8 plus 1 by 4 into P of B is 1 by 2 into P of C is 5 by 8 plus P of A dash. P of A dash is 1 by 4 into P of B dash is 1 by 2 into P of C is 5 by 8. So you're getting all this. Now you have common denominator over here, 4 to side 8. 8 is a 64 if I take. it as common, and if I add the numerators, that is 3 3s are 9, 9 plus 5, 9 plus 5, 9 plus 5, or एक minute, just a bit. P of C is yes, it is just a bit. This is C dash. This is C dash, so this is 3 by 8. C dash, this is 3 by 8. So 5, 3 is 9, 9 plus 3 is 12, 12 plus 5 is, here you will get as 17. So you are getting here things as 17. I'll just erase this again. That is, this is 3, 3 by 8. Now this is what you're getting, and as A, that is 17 by 64 is your first answer. Now the second case is not be hit by any one of them. That is, when I say is not hit by any one of them, that means A is also not hitting, that is complement, B is also not hitting, and C is also not hitting. So if I multiply this, that is P of I, if I use independent event, P of A dash, P of B dash into P of C dash. So what will I get? Just multiply them. That is P of A dash, that is 1 by 4 into 1 by 2 into 3 by 8. 1 by 4 into 1 by 2 into 3 by 8. So this comes out to be 3 by 64. This is question number B. Now let's come to question number C. That is, what it says is probability that it is hit. Probability that it is hit means that is hit by at least one of them. See, probability of getting a hit means probability that it is at least hit by at least one of them. Okay, at least one of them hits it. So what is probability of at least one? Probability of at least one is 1 minus probability of none. That is, no one hits. Probability of at least one of them is 1 minus probability of none. That is 1 minus probability of none means probability of none, that is probability that no one hits. That is what we have calculated just now, P of A dash B intersection B of D dash intersection C dash, which is 1 minus 3 by 64, 3 by 64. 1 minus 3 by 64 is actually 61 upon 64. So this is probability that it is hit. The last one will be probability that is exactly hit by two of them. Probability that exactly hit by two of them means, if I consider exactly by two of them means A and B, let's say A and B hit, but C does not hit. This is the first case. Or I can say, so these are the three cases over here. As you can see, the three cases are here are the first and the second hitting, and third not hitting. Second and the third hitting, the first not hitting. First and the third hitting, second not hitting. So C is not hitting over here, A is not hitting over here, and B is not hitting over here. So these are all independent event again. So I can say P of A into P of B into P of C dash plus P of A dash into P of B into P of C plus P of A into P of B dash into P of C. So if I calculate this, what will I get? P of A is 3 by 4 into 1 by 2 into P of C dash is 3 by 8 plus P of A dash is 1 by 4 into P of B is 1 by 2 into 5 by 8 plus P of A is 3 by 4. P of B dash over here is 1 by 2. P of C over here is 5 by 8. So here I can clearly see the answer is, in the denominator you get 4 to side 8, it's a 64 as the common denominator, and this will be 9 plus 5 plus 15. 9 plus 5 plus 15, that is 29 upon 64 is your answer. The next question here is the probability that a student X solves a problem in dynamics is 2 by 5, and the probability that student Y solves a problem is 1 by 4. 2 by 5 and 1 by 4 are the probabilities. Okay, these are the probabilities given to you. So we can just write events A and B over here. That event A is X solves the problem, and event B is Y solves the problem. Okay, so probability of A solving it is 2 by 5, and probability of B solving it, sorry, not, Y solving it is 1 by 4. So probability of A, that is X solving it, is 2 by 5, and Y solving it is 1 by 4. So I can find the complementary probabilities over here. That is, I can find P of A dash, that is not solving it, is 1 minus P of A, that is 1 minus 2 by 5, which is 3 by 5. Then now, what do I want is P of B dash is 1 minus P of B. 1 minus P of B is 1 minus P of B, means 1 minus 1 by 4. It is 3 by 4. It is 3 by 4. So probability of Y not solving is probability of B dash. That is 1 minus 1 by 4. It is nothing but 3 by 4. So you get probability of A dash, that is X not solving. This is probability of B dash, that is Y will not solve the problem. So you have the probabilities now. Now we can solve this. So let's see how to solve this. So let's see what are the events given over here. The first event that will be given for the first is problem is not solved. Problem is not solved means A, X is also not solving it, and Y is also not solving it. That is A dash intersection B dash. Now these are independent events, so I can just multiply them. Just multiply and get the answer. That is P of A dash into P of B dash. So P of A dash into P of B dash. P of A dash is, A dash means 3 by 5 into P of B dash means 3 by 4. That gives us 9 by 20. So this is probability of A dash intersection B dash. Now second is problem is solved. Problem is solved means what? A and B both will solve it. Okay, but what do I mean? That is problem is solved means at least one of them will solve it. At least one of them will solve it. At least one of them will solve it means, at least one means 1 minus probability of none. That is 1 minus no one will solve it. That is no one will solve it. So when I say no one will solve it means it is nothing but A will also not solve it and B will also not solve it. That is 1 minus P of A intersection B dash. That is what we have got as 1 minus 9 by 20 is 20 minus 9 is 11 by 20 is your answer. The third question here is probability solved exactly one of them. Exactly one of them means I can say A is solving, that is X is solving it and Y is not solving it, or Y is solving it and X is not solving it. So this is P of A into P of B dash plus P of A dash into P of B. So when I solve it, P of A is 2 by 5 into 3 by 4 plus 3 by 5 into 1 by 4. So what do you get by this? This is your common denominator over here again. That is 20. And 6 plus 3 is 9. This is what you get. That is 9 by 20 is your answer.